All right, let's go ahead and continue here on section 6.5, properties of logarithms. And we split this up into two sections. So now what we're going to take a look at is taking our logarithms and first being able to condense the logarithmic expressions. So let's take a look right here at number 9. First off, pretty straightforward. Look, we have log base 2 of 3 plus log base 2 of 8. And hopefully we remember, hey, when we're dealing with addition right here and in our logarithms, we end up adding the two terms together, or sorry, multiplying. So this 3 and 8, and now we could do what I'm going to do next because we do have the same log base, is that this will turn into log base 2, and then we go ahead and take 3 times 8, and that gets us 24. So this now simplifies down to log base 2 of 24, and we have now condensed our logarithm. But of course, it's never that easy, so let's go ahead and step it up another notch and take a look at number 10. So I have log base 5 of 4 minus 2 times log base 5 of 5. Let's start off right here, kind of like our order of operations. First, I do know that hopefully you recognize the fact that, hey, the minus means that we're going to be dividing our logarithms here. But first, before that, remember we have this 2 out in front, okay, in front of the log base 5 of 5. And what do I do with that? Well, remember we talked about powers in 6.5a. Let's go ahead and take that 2, and then we're going to rewrite it where it's now an exponent. Okay, so I'll go ahead and let's just put it all right there. I want to take that 2, turn it into an exponent. So let's rewrite this. I now have log base 5 of 4 minus log base 5, and then we have 5 to the second power. And then let's go ahead and simplify things out. We have 5 squared, and that becomes 25. So I'll show all the steps right here for you. So make sure you have that in your notes. And then we have ourselves log base 5 of 25. And then at this point, we're at the final stage of our problem where we condense things out. And I have log base 5, and then we're going to put 4 over 25. And we're going to divide because we have ourselves we use the quotient property. I would recommend, as you can see here, I put parentheses over the 4 over 25. 1, it helps for grouping. 2, neatness, organization, although you may not have to have it. However, as we start getting to like the next problem, I think you'll find that it's important for us to group things accordingly. So in number 11 right here, we'll start off, we'll do the same thing what we did with number 10 with this 3 ln 6x. So let's go ahead, we'll take that 3, we'll turn it into an exponent. So I'll rewrite this as ln 6x, and then raise this to the third power. Now there's a reason why I did that, because if you look, if you don't, what ends up being the problem and why students get this question wrong, let me rewrite this for you, make it a little bit neater, is that, remember, we have to take that 3 becomes the exponent. And then if you don't put the parentheses there, you may think it's just 6x to the third power, and then you call it a day. But that's actually not the case right here. So if you put in parentheses, hopefully you realize, oh, hey, this is 6x to the third power. 6x times 6x times 6x. So now I'll go ahead and simplify this out, and 6x times 6x times 6x is ln, and then we have ourselves 216 x to the third. Now we go ahead and use the the product property because we have the addition sign right here. And so I have now, let's take 216x to the third, and then we'll multiply that by 4y. Okay, we can multiply these together. And so now 216 times 4, it's 864. X to the third y. And there you go. We have now simplified number 11. All right, so when you look at these problems, make sure you deal with the power property first before you start doing all kinds of other things with the quotient product properties. Okay. Now on number 12 right here, we've got a few more things going on. We've got 3 terms. Let's treat this like you would order of operations as well. So that's going to be the next important thing right here. Remember, order of operations, if all things are the same, like in the same level, then you got to start going from left to right. So to start off with, let's go ahead and worry about the first 2 terms, the log base 2 of 625 minus log base 2 of 125. We have ourselves subtraction, so that means we're dealing with the quotient property. So there we go, log base 2 of 625 over 125. And then let's go ahead right here, let's do some reorganizing with this 1/3. And we're going to go ahead and put that as an exponent. So now I have plus, I've got log base 2 27. I'll put that in parentheses to the 1/3 power. So now I have 27 to the 1/3 power, but we can go ahead and rewrite that, and that's the same thing as taking the cube root of 27 if you were to rewrite that exponent as a radical. So this right here now becomes log base 2 of 3. Let's go ahead and simplify it right here. That's 625 over 125. And we can simplify that. So let's go ahead and do that right now. And that becomes log base 2 of 5. So now we can come to our final step right here. We got log base 2 of 5 plus log base 2 of 3. We're adding, so therefore we have our product property. And so we go ahead and multiply 5 times 3, and we have log base 2 of 15. Okay, next up. Let's go ahead and worry about in number 13, the first 2 terms. I'll go ahead and underline that. And so since we're subtracting, we do have, that means we are dealing with our quotient property. And so this becomes log base 2 of 6 over 2y. All right. Let's go ahead next up over here. We've got 2 times log base 6 of 3x. And so let's go ahead and put plus log base of 6, 3x. We'll raise this right here, put that in parentheses into the second power. All right. So let's go ahead and do some simplifying right here. I could go ahead and put this as log base 2, 6 over 2y. That simplifies down to 3 over y. And then with the log base 6, 3x to the second power, that becomes log base 6. And then it becomes 9x squared. So last thing right here, since we have the addition sign in between, we can go ahead and multiply things together, combine our terms. And so we got negative log base 2 of 3y, 3 over y. we're going to go ahead and multiply, but let's keep that negative. So we got negative log base 2. We multiply things, multiply across with our fractions. 3 times 9x squared is 27x squared over y. And there you go. We have now simplified number 13. All right. We're going to go up and take a look at some part of our notes that we didn't talk about, and that is this change of base formula. And so, what is this change of base formula, and what is it all about? Remember, earlier on, what I kept saying in this chapter is that, look, even though you have a calculator, you can't use it because most calculators do not have a log function that allows you to use change the log base other than 10. Your calculator defaults to 10 unless you have a little bit more advanced scientific calculator that has like log base, y of x. Like it automatically, there's a button there and allows you to fill in the blanks. So it's like, well, what do you do if you don't have that type of calculator? Well, the change of base formula allows you to take care of business even if your calculator doesn't have that function. So how does it work? Okay, it says if a, b, and c are positive real numbers, b doesn't equal 1, c doesn't equal 1, then you can go ahead and rewrite the function as what you see there. Okay, now I would pay more close attention to this. It's the same thing, but the problems you'll look at will be more pertinent to what you see right there that I circled in red. It says log base c of a is equal to log a over log c. Okay, well, what does that mean? Let me give you an example right here. If I have, let's say, log base 2 of 5. What that means is that I could go ahead and rewrite this as log 5 over log 2. And if you put log 5 over log 2 in your calculator, then you will be able to figure out what log base 2 of 5 actually is. And the same applies to ln. Okay, so it's saying right here, look, if I have log base 2 of 5, I could also rewrite this as ln of 5 over ln 2. You try that in your calculator, and you'll see that it works out. So let's go ahead and now that we know that, we can go ahead and take a look at number 14 right here. Use the change of base formula to evaluate the logarithm. Okay, so number 14, pretty straightforward. We'll go ahead and rewrite this, and so we have log 17 over log 3. Okay, just like that. Remember, the 17 happens to be the a, and then the 3 happens to be the c. And so if you put everything together in the rule that was shown for the change of base formula, you could put that. That's how I put the numbers in those spots, or why I put them in those spots. So for number 15, if I were to rewrite this, we have log 294 over log 9. Change of base, you can evaluate that using your calculator. They round to the nearest thousandths. So the first one right here for number 14, that actually becomes 2.579. For number 15, log 294 over log 9. So practice this on your calculator. Make sure that you do get the same answer. If not, something is wrong. Let's take a look next at number 16. All right, let's see what we can do right here. I now go ahead and write this as log 4/9 over log 7. Okay, so we've got our fractions. We keep the fractions there. We'll go ahead and simplify it. Now, in your calculator, you are going to need to put parentheses probably around that 4/9 for it to work. Otherwise, it's going to be like log 4, and then your calculator is going to calculate that, then divide it by 9, then divide it by log 7. Okay, so if you don't put the parentheses there, most likely it's going to do a lot of more extra dividing than you want it to. And so in your calculator, you got negative 0.417 right there. Show it to you one more time with number 17. We can go ahead and rewrite this as log over log of 110, or 1 over 10, divided by log 6. Now remember, you're saying, what's the base? Log base 10. Okay, that's why you can use your calculator. So using the change of base, it automatically allows you to use the log button because we are dealing with log base of 10. So then from there, we go ahead, plug in your calculator. You should get negative 1.285. And there you go. All right, so we finished up section 6.5, properties of logarithms now. Go ahead and make sure, you could use your calculator here, use a scientific calculator, see and make sure it works. Understand that change of base, and make sure that you can use those properties of logarithms.